Welcome back. Okay, so in this section, Chapter 2, Section 7, we're going to go back and we're going to try and remember what we know about inequalities. Then we're going to take a brief look at how to handle single-step equalities, and then I've got a couple cautionary things I need to show you at the very end. So let's just start with a quick review of the basics of inequality. So these are the four basic inequality symbols. You've got greater than, so it's where it's telling you that the solution are all the numbers greater than a particular number, and it graphs like this. Now, if we include that number, then it becomes this symbol, greater than or equal to. And instead of having a hollow circle, we're going to fill it in so it's a solid circle. So now the graph is telling me to include that number, and it's everything greater than that. If we go the other direction, there's the less than symbol. Okay, so now we're back to a circle that's not filled in because we're not including that number. We're getting infinitely close to, but we're not including that number. And we have all the numbers less than that. And if it's less than or equal to, now we fill in that circle, and that means everything less than that circle as well. Okay, so just a reminder, those are the basics of inequalities. So just a quick look at graphing them. If I asked you to graph x is greater than -2, just draw a number line. Identify this as -2. You don't have to put 0. I assume you know where 0 is relative to -2. What you have to get right is that this is greater than. It's not equal to, so it's going to be an open circle. I'm not going to fill it in. And it's greater than. So all the numbers greater than -2 are to the right on a number line. So we're shading that direction, okay? Another one, let's do x is less than or equal to 5. So here's my -5 on the number line. Put a circle, but this time it's or equal to, so I'm going to fill that in. And it's less than, the numbers less than -5 are to the left on a number line. So we have that. So that's just a quick lesson on how to graph them. Now, what does that look like when we're doing problems? Okay, so here's a problem. And I guess the title's a misnomer. The title says single step. We're jumping right to 2 steps. So here's the problem. Now, if this were an equal sign, you'd know exactly what to do. If it said 2x minus 6 equals 15, you'd add 6 to both sides, then you divide both sides by 2. Now, what if I told you it's exactly the same? The process, the steps you take to solve an inequality are exactly the same as everything you've learned about equations, with 2 caveats, and I'm going to talk about those caveats in just a second. So if this is the same, I know I'm going to add 6 to both sides. Wrong color. I'm going to add 6 to both sides. -6 and the 6 cancel out. I have 2x. Bring down is the less than or equal to, and you have 21. Divide both sides by 2. 2's cancel. X is less than or equal to 10.5. So it's the same thing. The process, the steps are the same, whether it's an equation or an inequality, except there are 2 distinct differences. We're going to talk about those next. So we need to make some notes on multiplication and inequalities, okay? So let's start with something that we can all agree with. I'm going to put a statement up here, and it says 4 is less than 8. And I think we can all agree that that's a true statement. This is true, okay? Now, if I were to multiply both sides of this equation by 2, so I've got 4 times 2 and 8 times 2, what inequality would I put there? Well, okay, 4 times 2 is 8, and 8 times 2 is 16. 8 is still less than 16. So this is still true. However, so I'm going to put a however here. Let's go back to our original statement of 4 is less than 8. Now this time, I'm not going to multiply by a positive number on both sides. I'm going to multiply by a negative number on both sides. So I've got 4 times negative 2 and 8 times negative 2. Well, what happened? So 4 times negative 2 is negative 8, and 8 times negative 2 is negative 16. So what happened to the inequality symbol? You should be looking at this and recognizing that it switched. It switched directions from less than to greater than. So our note here is that anytime you multiply an inequality by a negative, you must switch the direction of the inequality symbol, okay? So anytime you multiply an equation or inequality by negative 2, you have to switch the direction of the inequality symbol, okay? And that's only for inequalities, all right? Now, notes on division and inequalities. So let's start with the same true statement. Wrong color. 4 is less than 8. That is still true. Okay, I don't think anyone's going to argue with that. Now I'm going to divide both sides by 2. 4 divided by 2 is 2, and 8 divided by 2 is 4. So this inequality is still less than. This is still a true statement. This is still a true statement. But watch what happens when I turn that from a 2 to a negative 2. All right? So I'm going to put the however in here. So we'll go back to 4 is less than 8. But now I'm going to divide by negative 2. 4 divided by negative 2 and 8 divided by negative 2. 4 divided by negative 2 is negative 2. And 8 divided by negative 2 is negative 4. Well, now think to yourselves, which one is greater? Which one is less? Okay? And you should see that the inequality symbol switched directions. Negative 2 is actually greater than negative 4. So the next note we have is anytime you divide an inequality by a negative, you must switch the direction of the inequality. So when you're doing inequality problems, you really have to keep an eye out for when you're multiplying or dividing by a negative, you have to change the direction of the inequality, okay? That's when you're multiplying or dividing by a negative. If the things you're multiplying or dividing to are negative, that doesn't matter. It's the thing you're multiplying or dividing by that changes the direction. All right, just a quick reminder. Now, when you go to do the worksheet, you're going to see problems. You already know how to solve them because you already know how to solve single and multi-step equations. It's the same process.